What is tunnel diode? A tunnel diode is a heavily doped p-n junction diode in which the electric current decreases as the voltage increases. In tunnel diode, electric current is caused by tunneling. The tunnel diode is used as a very fast switching device in computers. It is also used in high-frequency oscillators and amplifiers. The circuit system of tunnel diode is shown here. In tunnel diode, the p-type semiconductor acts as an anode and the n-type acts as a cathode. The germanium material is commonly used to make the tunnel diodes. They are also made from other types of materials such as gallium arsenide, gallium antimonide, and silicon. We know that an anode is a positively charged electrode which attracts electrons, whereas cathode is a negatively charged electrode which emits electrons. In tunnel diode, n-type semiconductor emits or produces electrons, so it is referred to as the cathode. On the other hand, p-type semiconductor attracts electrons emitting from the n-type semiconductor, so p-type semiconductor is referred to as the anode. Let's see how does the tunnel diode works. Step 1. Unbiased tunnel diode. When no voltage is applied to the tunnel diode, it is said to be an unbiased tunnel diode. In tunnel diode, the conduction band of the n-type material overlaps with the valence band of the p-type material because of the heavy doping. Because of this overlapping, the conduction-based electrons at n side and valence band holes at p side are nearly at the same energy level. So when the temperature increases, some electrons tunnel from the conduction band of n region to the valence band of p region. In a similar way, holes tunnel from the valence band of p region to the conduction band of n region. Step 2. Small voltage applied to the tunnel diode. When a small voltage is applied to the tunnel diode, which is less than the built-in voltage of the depletion layer, no forward current flows through the junction. However, a small number of electrons in the conduction band of the n region will tunnel to the empty states of the valence band in p region. This will create a small forward bias tunnel current. Thus, tunnel current starts flowing with a small application of voltage. Step 3. Applied voltage is slightly increased. When the voltage applied to the tunnel diode is slightly increased, a large number of free electrons at n side and holes at p side are generated. Because of the increase in voltage, the overlapping of the conduction band and valence band is increased. In simple words, the energy level of an n-side conduction band becomes exactly equal to the energy level of a p-side valence band. As a result, maximum tunnel current flows. Step 4. Applied voltage is further increased. If the applied voltage is further increased, a slightly misalign of the conduction band and valence band takes place. Since the conduction band of the n-type material and the valence band of the p-type material still overlap, the electrons tunnel from the conduction band of n region to the valence band of p region and cause a small current flow. Thus, the tunneling current starts decreasing. Step 5. Applied voltage is largely increased. If the applied voltage is largely increased, the tunneling current drops to zero. At this point, the conduction band and valence band no longer overlap and the tunnel diode operates in the same manner as a normal p-n junction diode. If this applied voltage is greater than the built-in potential of the depletion layer, the regular forward current starts flowing through the tunnel diode. The portion of the curve in which current decreases as the voltage increases is the negative resistance region of the tunnel diode. The negative resistance region is the most important and most widely used characteristic of the tunnel diode. A tunnel diode operating in the negative resistance region can be used as an amplifier or an oscillator. Now let's look into the advantages and disadvantages of tunnel diodes. Advantages: long life, high speed operation, low noise, low power consumption. Disadvantages: tunnel diodes cannot be fabricated in large numbers. Being a two-terminal device, the input and output are not isolated from one another. Applications of tunnel diodes. Tunnel diodes are used as logic memory storage device. They are used in relaxation oscillator circuits. It is used as an ultra high speed switch, also used in FM receivers.